in short supply, we may have the other chemical in excess. So stoichiometry, that's what stoichiometry is all about. We are trying to quantify in terms of grams and moles about a chemical reaction here. Okay, so stoichiometry would provide quantitative information about chemical reaction so that we can figure out if we have certain, say, 25 grams of hydrogen gas, 25 grams of oxygen gas, how much water can we produce based on the quantity here? So that's what stoichiometry is all about. And given a chemical reaction equation, this is a sentence in the language of chemistry. We need you to understand what this sentence is telling you. What this sentence is telling you here is that given a balanced chemical reaction equation, for every mole of barium chloride, it reacts with 1 mole of sodium sulfate. As a result, you produce 1 mole of barium sulfate and 2 moles of sodium chloride. So the number in front of a particular chemical represent the moles. So it's a molar ratio thing. Okay? So when the number is 1, you don't need to put the 1 in there. But when it's anything other than 1, you have to put the numbers in there. So what this sentence is telling you in the language of chemistry is that the molar ratio about the chemicals involved in this chemical reaction. In plain English, 1 mole of barium chloride react with 1 mole of sodium sulfate and will produce 1 mole of barium sulfate and 2 moles of sodium chloride. So this is what we need you to be able to tell. We will not, as you can see, I always say this, chemistry is much easier than English. And when you try to express something in English and you have this many different words in that sentence there, and in language chemistry, you just put 4 formulas in there, and people would understand what's going on. And you will need to understand what's going on with the chemical reaction there. Okay, so try this one. Glucose, oxygen, carbon dioxide, water. This is something that's just happening right now inside your body. When you take the food in there, when you drink the beverage there, glucose, the sugar in the food, in the beverage there, will react with oxygen gas. You breathe in the oxygen gas. And as a result, it generates carbon dioxide, generates water, releases tremendous amount of energy. And you use that energy to do everything that you do. Okay? So how do we express this particular chemistry sentence in English? Well, 1 mole of glucose react with 6 moles of oxygen gas, producing 6 moles of carbon dioxide, 6 moles of water. So that's what we want you to be able to do. When we give you a balanced chemical reaction equation, you understand these numbers represent the molar ratio. So every mole of glucose will react with 6 moles of oxygen. And when the reaction is finished, you will have 6 moles of carbon dioxide and 6 moles of water produced. And this is just the matter aspect of the chemical reaction. In chapter 6, we will look at the energy aspect of the chemical reaction. So for this particular reaction, something that you can add after water is certain amount of energy in the form of either heat or other types of other forms of energy here. So this reaction releases tremendous amount of energy there, and that's why you need to eat and drink pretty much all the time, so that you have enough energy to sustain your everyday life activities. Okay, so this is what we need you to be able to do. Given a balanced chemical reaction equation, you know what it means. Okay, and these numbers are put in there so that you have the same number of carbon atoms on both sides of the equation. You have the same number of oxygen atoms on both sides of the equation. You have the same number of hydrogen atoms on both sides of the equation. Now, when you look at a chemical reaction equation here, now that's another example. If you have aluminum reacting with oxygen, generating aluminum oxide there. Now the chemical equation shows you who are the reactants, who are the product. Now by convention, we always put the reactants on the left side of the equation, left side of this arrow there. Okay? And then the products are always being put on the right side of the equation. So when you look at the balanced chemical reaction equation, you know who's reacting with whom, and then what is being produced. Okay? And also the relative amount in the reaction. The number in front of each of the chemical, or what we call the stoichiometric coefficients there. Now those coefficients represent molar ratio, okay, or the number of particles there. Because number of moles is equivalent to the number of particles. Each mole has, what's that number? Avogadro number, 6.02 times 10 to the 23, and that many number of particles, just like each dozen has 12 particles. Each doesn't have 12 counts of anything in there, okay? So these numbers, 2 and 3 and 4, in front of the chemical represent the molar ratio. It's a ratio between the particles, in the amount of moles there, and that also represent the number of particles of each of the chemicals involved in there. Now, when you write out the balanced chemical reaction equation, sometimes, more than often, you will see a little symbol after each chemical there. S, G, L, AQ. S for solid, G for gas, L for liquid, and AQ represent the chemical is dissolved in aqueous solution, in water solution. Okay. So when we're asking you to balance chemical reaction equations, there's sometimes we do not put it in there because when you're only looking at the matter aspect of the chemical reaction there, we just want to know how much do we have and how much can we get. Okay. However, if you're looking at the energy aspect of chemical reaction there, well, sometimes a solid state chemical have a different energy requirement than the liquid or gas state chemical for the same chemical there. So you have to put that in there if you were considering the amount of energies involved in the chemical reaction there. So when you look at the chemical reaction equations in your textbook, sometimes you see those S and L and G and AQ, and sometimes you don't. And we just need you to, if we put that information in there, we just need you to remember S for solid, G for gas, L for liquid, AQ, that means this chemical reaction is happening in aqueous solution, in water solution. Okay, so given a chemical reaction equation, with that one simple line of equation there, there's a lot of information presented in there. Okay, so if you look at this equation there, we can state that 4 aluminum atoms will react with 3 oxygen molecules and give you 2 formula units of aluminum oxide. Or we can say 4 moles of aluminum react with 3 moles of oxygen gas to give you 2 moles of aluminum oxide. So that's what the chemical equation is all about. And it quantifies the amount of chemicals involved in terms of reactant and product, and you can predict, based on the quantity there, you can predict how much is required if you want to produce a certain amount of product, or if you have so much reactant, and how much product can you predict? Can you produce? So the prediction, the quantification of the chemical reaction makes it possible for us to make predictions there and to do calculations. Okay, so the importance about the balancing the chemical reaction equation is that we have to follow that laws of conservation of matter. We know we cannot create nor destroy matter. Okay, so in this case, we say the same number of atoms must present in a chemical reaction at the beginning and at the end, because you cannot destroy them. You can't just eliminate those atoms there. And those atoms are basically, in chemical reactions, they're basically just recombining with one another, forming a different compound. Okay, so in this case, since matter is conserved in a chemical reaction there, chemical equation must be balanced for mass. We have to have